Hello everyone, today I Kavanayamai from Sri Venkateshwara College of Engineering is here to do my assignment on the topic Markov chain. So let's start. Introduction to Markov chain. Markov chain is a mathematical model that represents a sequence of events in a system. It is a stochastic process where the future state of the system depends only on its current state. Markov chains are widely used in various fields such as physics, computer science, and finance. Here is the image that shows Markov chain transition probabilities. Components of a Markov chain. States. A Markov chain consists of a set of states that the system can be in. Transition probabilities. Each state has associated probabilities of transitioning to other states. Transition matrix. A matrix that represents the probabilities of transitioning from one state to another. Markov property. The Markov property states the future state of the system is independent of its past states, given its current state. This property allows for the simplification of complex systems by focusing only on the current state. Markov property is crucial in the analysis and prediction of various real-world phenomena. There are also several properties that Markov chains can have, including irreducibility. Markov chain is irreducible when it is possible to reach any state from any other state in a finite number of steps. Aperiodicity. A Markov chain is aperiodic when it is possible to reach any state from any other state in a finite number of steps, regardless of the starting state. Recurrence. A state in Markov chain is recurrent if it is possible to return to that state in the finite number of steps. Transience. A state in Markov chain is transient if it's not possible to return to that state in a finite number of steps. Ergodicity. A Markov chain is ergodic if it's both irreducible and aperiodic and if the long-term behavior of the system is independent of the starting state. Reversibility. A Markov chain is reversible if probability of transitioning from one state to another is equal to the probability of transitioning from that state back to the original state. Types of Markov chains. Homogeneous Markov chain. The transition probabilities remain constant over a time. Non-homogeneous Markov chain. The transition probabilities change with the time. Finite Markov chain. The number of states is finite. Markov chain diagram. A Markov chain can be represented graphically using a diagram. Each state is represented as a node and the transition probabilities are represented as directed edges. The diagram provides a visual representation of the system's dynamics and helps in understanding the state transitions. Calculating state probabilities. The probability of being in a particular state at a given time can be calculated using the transition matrix and initial state probabilities. By multiplying the initial state probabilities with the transition matrix repeatedly, we can calculate the probabilities of multiple time steps. The long-term behavior of a Markov chain can be analyzed by calculating the stationary distribution. Here is the image that shows how to find the steady state probability of Markov chain. Applications of Markov chain in business. Stock market analysis. Markov chains can be used to model and predict stock price movements. Customer behavior analysis. Markov chain can help understand and predict customer purchasing patterns. Risk analysis. Markov chain can be used to model and analyze various risks in business operations. State 1, State 2, State 4, and State 3. In State 1, Component 1 working, Component 2 also working. State 2, Component 1 failed, Component 2 working. State 4, Component 1 failed, and Component 2 failed. State 3, Component 1 working, Component 2 failed. Applications of Markov chains in natural language processing. Speech recognition. Markov chains can be used to model and recognize speech patterns. Text prediction. Markov chains can be used to predict the next word in the text based on previous words. Machine translation. Markov chain can be used to model and translate natural language sentences. Markov chain can be used for modeling biological systems, the spread of a disease through population. In such case, the states of the system might represent the number of individuals in a population who are susceptible, infected, or immune to the disease, and the transitions between states might be influenced by several factors such as the rate of the infection and the effectiveness of the vaccine. By analyzing the probability of transitioning between different states, it is possible to make predictions about the future spread of the disease and the effectiveness of various control measures. In order to analyze and predict the behavior of a Markov chain, it is necessary to define the states of the system and the transitions between those states, as well as the probability of transitioning between each pair of states. This information can be represented using a transition matrix, which is a matrix of numbers representing the probability of transitioning from one state to another. Limitations of Markov chains. Markov chain assume that the future state depends only on the current state, ignoring any other state. The, current, the, the accuracy of predictions depends on the quality of the transition probabilities and the initial state probabilities. Markov chains may not be suitable for modeling complex systems with intricate dependencies. Here is an example of Markov chain. The TPM of Markov chain is given by P equals to 1 by 2, 0, 1 by 2, 1, 0, 0, 1 by 4, 1 by 2 and 1 by 4. Distribution is P of 0 equals to 1 by 2, 1 by 2 and 0. And we have to find P2 1 by 1 3, P2 2 3, P2 and P2 1. So first we are finding the P square by multiplying the same matrix 2 times, and then we get the resultant matrix. To find P2 we multiply P0 into P2 to find P of 2. Conclusion. Markov chain provide a powerful mathematical framework for modeling and analyzing a sequential system. They find applications in numerous fields, including business, natural language processing, and more. Understanding the principles and limitations of Markov chains is crucial for effectively utilizing them in various domains. Thank you.